Welcome to another episode of Demystifying MCPs. So far, we've seen why MCP exists and when LLM systems break. Now, let's look at how MCP is actually structured. MCP is not inside the model, and it's not the tools themselves. It sits in between, acting as a structured interface. At a high level, MCP architecture consists of four main components. Each has a clear responsibility. The model is the reasoning engine. It decides what to do, but it does not directly access tools or data. The MCP client sits close to the model. Its job is not to run tools or fetch data. Instead, the MCP client translates the model's intent into a structured request that the rest of the system can understand. For example, the model might think, summarize the project folder. The MCP client converts that intention into a clear, structured request. Not raw text, not guesswork, but a formal MCP message. The MCP server lives on the system side. It does three critical things. First, it exposes available context and tools in a discoverable way. Second, it enforces permissions and boundaries. Third, it ensures every request follows a defined structure. Tools and data sources sit behind the MCP server. They are never accessed directly by the model. When the model needs something, it makes a structured request. That request flows through the client, server, and finally to the right tool. This separation is intentional. It keeps reasoning, orchestration, and execution independent and reliable. Instead of guessing, the model can discover what tools exist, what they do, and how to use them through MCP. Unlike prompts, MCP interactions are structured. This removes ambiguity and reduces failure. MCP allows multiple models to safely use the same tools, without custom wiring for each one. Real-world system impact. MCP architecture enables real systems like IDE assistants, enterprise agents, and scalable workflows. So the key takeaway is, separating reasoning from execution in MCP architecture is what makes AI systems reliable. In the next episode of Demystifying MCPs, we'll focus on how MCP handles context, files, memory, and state, without breaking models. Stay curious.